Today we're going to look at how you can navigate file structures. We're going to look at more data, and we're going to see how associations can be used. First, let's talk about getting file paths. If you want to import a file from either your computer or from the internet, you can use the function import. If you type in import and then square brackets, you notice that there's a little red caret here that appears, and that's an indication that you need an argument, at least one argument. That's true of any function. If you are missing arguments, it'll give you that indication. So if you want to import from your computer, you can use the file path item from the insert menu. Select file path, and that brings you to a point where you can locate a file. Here I'm in the directory of that file that I want to look for. It's a sample grades file we've seen already, and simply click on choose, and the file path as a string will appear, and it looks like I had the cursor at the wrong place. So I should have had it between the brackets. I had it to the left of the left bracket, so I'll have to just make a quick edit. But otherwise, I've got this long string that I certainly don't want to type, but using the file path item from insert puts it into the proper location. The other thing you can do is, if you're looking for a file online, you can go to your browser, and let's suppose we want to find an image of the Red Sox logo. Search for Red Sox image, maybe, and there are plenty of those. I'll just click on one of them, view the image, and at this point I can copy the URL and then go back to Mathematica and insert that into the import expression. And when I pasted it, when I copied, I didn't put quotes around it, so that was, you have to put quotes around the URL and then evaluate this. I have a semicolon at the end here, so I don't see the output unless I remove that. Anyway, so there it is. Okay, so that's a way to import. Now, if you want to not have to go to the internet for a file, but you want to be able to use that image occasionally, I'm not sure about copyright protection here, but if you assign this a value, like Sox image equals, you can evaluate this expression in place. So you select the import expression, and under evaluate in place. So what that's going to do is Mathematica is going to evaluate the expression, but not put it as an output. It'll have it as the right side of the set expression. So Sox image is this. At this point now, you can put a semicolon at the end, evaluate this, and now if I want to use this image for something else, all I have to do is evaluate this set command, and Sox image has that value. You can use it. But the main thing is, either you can use the file path item to get something off your computer, or paste the URL off the internet. There are a lot of ways to navigate the file structure of your computer. I'll give you a few tips here, and the first is to identify the home directory. Home directory is a constant, it's a system name anything that starts with a $sign is a system name. And if you evaluate home directory, you'll find the name of a directory. And when you open Mathematica, and if you were to try to import something or save something, that would be where Mathematica would look if you didn't give it any further direction. At any time, if you evaluate the expression directory, you need the empty square brackets here, it tells you the current directory you're in. Okay, so as you begin, the value of directory will be home directory if you start a new session. I find that in working with files, it's convenient to have the data and the notebook that manipulates the data in the same location. So I use notebook directory frequently. So if you evaluate notebook directory, this gives you the directory in your computer where the notebook that you are working in is located. So what I've done here is I've created a directory, and in addition to this notebook, I've got various files we're going to use in this session. So if you use the function set directory, this changes the current directory from, in this case, home directory to the notebook directory. So set directory, notebook directory, and now I can look through files in that particular directory, or I can save files there. And the expression file names will give you a list of the file names that are in that directory. This time, the square brackets can be empty, or you can put in a pattern. For example, if I want all the CSV files in the current directory, I can type the string asterisk for the wildcard.csv, and this will give me a list of all of the CSVs in the current directory. Or all the notebooks. You can also identify the directories that are in the current directory. Among the file names, I can select the ones that have a type that's directory. Okay, so there's looks like 3 directories here: the baseball data bank, images, and this NBA player stats since 1950. Those are directories. So I can also look at the files within the images directory by this specification. So images slash a file name is a file name within the directories, the images directory. So putting an asterisk here will give me all the file names within that directory. So let's look at what's inside the baseball data bank directory. Okay, so going back to the images case, notice that the list, there's always this DS store, at least on a Mac, which you can pretty much ignore. Since it starts with a period, it's actually invisible. If you don't do this, look at this on your computer. But there's lowell.gif, there's mlogo.gif, and oldmanprime.png. These are the files within the images directory. And same here with the files within baseball data bank. There are 3 of them. One of them is the invisible DS store. So this is a way to look at the files. If we want to go deeper, we can set the directory to be images, In other words, right now, since we're currently in a directory that contains images as one of the subdirectories, if we do that, the current directory is now the images directory. And now if we evaluate file names, we get that same list of files, of images. The prefix, the images slash isn't there because we're currently in the images directory. We can go back, set the directory with the string double dot. What that does is it puts you up a level in the directories. So we're back to the previous directory, which we call class 8. Next, we're going to look at associations. Association is a basic data structure that many computer languages have, although the name is different. In Python, for example, an association is called a dictionary. And I think dictionary might be a little bit more standard name, but the idea is the same. Notation is slightly different also, but same idea. So I'm going to look at associations with a simple example right now, but we'll see how it can be useful for working with large sets of data. So I'm going to start by I'm going to create an association that describes the states that border the various New England states. So if you want to build up an association, the first thing you can do is if you're going to give it a name, we'll call it border states. You can set it to be an empty association. So border states is set to be this symbol here. It's less than 2 vertical lines, and greater than. That's an empty association. That's the value of border states. Now, there are different ways to build up an association. Normally you wouldn't do this one step at a time, but I can show you that it's doable. We can, for example, specify the set of states that border Massachusetts by a list of strings. So border states, and notice this is a little like a function. It's border states of the string Massachusetts is the list of strings which are New Hampshire, Vermont, Rhode Island, and Connecticut. So evaluating that, the value of border states now, you can see, is it's actually like a list of rules. It's only one of them though, enclosed inside of this association symbol that we started as being empty. So right now there's only, the Massachusetts is called a key, and the list that's associated with Massachusetts is the list of states that border. Right. We can append 2 border states. Okay, this is one way to add another item, and append 2 starts. The first item in append 2 is either a list or association. It could be either one. In this case, it's an association. We can append to this rule. New Hampshire borders Vermont, Massachusetts, and Maine. Now, what append 2 does is it actually changes the value of border states to include this additional list. Without the 2, if you just do append, you get an output that's the same thing, but that's not the new value of border state. Border states doesn't change, but append 2 will do that. So currently, the Border States Association has these 2 rules. And we can also go back and do the same thing as we did with Massachusetts. We can specify and now border states is this association contains 6 rules. And we can identify what are called the keys. The keys of the border states is the list of it's the states. Okay, they're the left-hand sides of the rules. And the values of border states are the list of right-hand sides. So that's it. That's what an association is. Now, this is such a small example that there's very little data involved, but with large groups of data, sets of data, it's a good way to organize information, and you'll see that in a little while.